All right, so we have Chapter 4, Section 2, Day 1, Degrees and Radians. So we're going to introduce radians. You may or may not have heard of radians before, so I'll just assume you have not. All right, so the first section, we're going to review a bunch of stuff that you should already know. Angles and their measures. And their measures. Some basics about angles. So if I sketch an XY coordinate plane, just X and Y, right there, I can put an angle on this by plotting a point at the origin, and then I'm going to put the first part of the angle, or the initial side, here on the positive x-axis. And then I'm going to sketch, it's going to be an acute angle, so I'm going to sketch it to here. And I'm going to show the motion of the angle from the initial to the terminal by putting a little arrow inside. There has to be something there, whether it's a symbol of theta or just a little curved mark. There's lots of ways to indicate that's the part I'm talking about, because this is an acute angle. But there's also the negative obtuse angle going, if you went the other direction, you'd have this really big obtuse angle going the other direction. So I have to indicate that I mean in between the acute angle in between the two segments. All right, so we have this side where I started is the initial side. On the positive x-axis. And over here where it ended, that is the terminal side. It's where it terminates. It stopped. All right, so standard position. So an angle is said to be in standard position if it begins on the positive x-axis. So, or it is in standard, to be in standard position always on positive x-axis. Just doing these bullet point definitions for you instead of a long formal definition. We don't need all that. We just need to know, understand it, know what it is. So it's in standard position is always on the positive x-axis. So the initial side is always on the positive x-axis. And the vertex at the origin. And just to be clear what I mean by the origin, even though I know all of you guys know this, the point 0, 0, that's what I mean by the origin. So the vertex of the angle is at the origin, and the initial side is on the positive x-axis. So this angle is in standard position. And when in standard position, you could have a positive angle. Positive angles their movement or rotation is in a counterclockwise direction, so opposite of the way a clock moves. So moves counterclockwise from the initial side. So here from the initial side, it went up, so let's just do another sketch. I am sketching this as an acute angle, just to be very clear. It doesn't have to be an acute angle, though. It could be any size angle. But to be positive means that it rotated in the counterclockwise direction from the positive x-axis, from the initial side. So I could have kept moving this all the way around. It could terminate down here in quadrant 3 or in quadrant 4. It doesn't matter where it terminates as long as it's moving in that direction. Or you could have a negative. and negative angles, positive moves counterclockwise, then you could guess probably that a negative angle is going to move clockwise. So if the rotation is in the same direction that hands on the clock move, then it is negative. Again, I'm just sketching an acute angle, but it could terminate in any quadrant. It is in standard position. Vertex is on the origin. The initial side is on the positive x-axis. But this time, I'm going to rotate in the clockwise direction. And it's shown right there. So this could have been a positive angle also. If I didn't have that little arrow inside the acute part, you wouldn't know. Was I talking about rotating around as a positive angle? Or am I talking about rotating the clockwise in the negative direction? But that little marking inside the angle shows us that it's negative. So positive or negative. Okay, so next up we're going to talk about radians. Radians. What are radians? And I cheated and I drew my circle ahead of time. But first we're going to talk about what they are, and then I'm going to get to that circle. Radians are a way of measuring angles. Bullet point. A way of measuring angles. So just like degrees are a way of measuring angles, and that's the one that you're used to, radians is another one. And something you definitely need to associate with radians is pi. The symbol pi. Because if you see pi, that is your indicator that's a radian, or in radian mode, or you're using radians. Always in radians. So your radian measure will always have a pi in it. So just go ahead and associate pi with radians. And know that for your answer or your measurements to be in radians, there must be a pi symbol in there somewhere. Unless in your calculator you entered the whole thing in with press the pi button and it rounded to a decimal. That, I guess, could trip you up, but we're not doing that. We're leaving fractions, exact answers. Pi will be in your measure. Okay, so let's put this more in terms that you're familiar with. So if we were to draw a circle that is centered around the origin, we're going to say that the length from the center to the circle is 1 unit. That doesn't really matter at this point, but that's what we're going to say. Here, this first quadrant is called quadrant 1. So quadrant 1, Roman numeral 1, capital I. And the quadrants rotate counterclockwise, so that makes over here quadrant 2. And I am describing to you the unit circle that we will use for trig. Just getting the basics of it. It's a circle centered around the origin. There's the x-axis and y-axis split this circle into 4 quadrants. Quadrant 1, 2. This one is 3. Quadrant 3. And quadrant 4. So if we go around and talk about angle measures in degree mode, or in degrees first, since we start here in the positive x-axis, we could say that point would be 0 degrees. Because there's not an angle there. It's a line at that point because it has The terminal side has not moved from the initial side. But if we rotate up here to the y-axis, we have moved 90 degrees. A right angle. Right angles are 90 degrees. If we move another 90 degrees, then we will be back to the x-axis. On the negative part of the x-axis is 180 degrees. Straight line is 180 degrees. It's also called a straight angle. We don't really use that term. It was used in geometry, but it might be familiar to you. So then if we added another 90 degrees, we would be down here at 270 degrees. And then from 270 degrees, if we add another right angle, we end up back to the start, and it would be at 360 degrees. So even though we have two different measures on the positive x-axis, they're representing this. The angle would look the same if we were to sketch that angle. The same as on a clock, noon and midnight look the same on a clock. These hands are in the same position. So you can think of the hands on a clock like your initial and terminal sides. So if you, at the beginning, we'll call it midnight, one time around get you to 12. Or you could go around again and then be, it just goes around and around. Same thing happens here, and the numbers just get bigger. So 0 degrees and 360 degrees are the same angle. So now if we want to put these in radians, radian measure, 0 degrees is going to be 0 radians. That's nice, right? Nothing crazy happened with 0. 0 degrees is 0 radians. We just got rid of the degree symbol. So halfway around the circle, I feel like it's easier to describe if we do this. From 0 all the way over to 180 degrees, halfway around the circle, that is pi radians. The radian measure at 180 degrees is pi. So if it's 1 pi to get halfway around the circle, what if we wanted to go a quarter of the way around the circle, half of that? Well, we would take pi and divide it by 2. So pi over 2. And we will use fractions. Leave it like that. That's exact. Pi over 2. So that tells us that 1 quadrant is pi over 2. So then after the 2 quadrants would be 2 pi over 2, which is pi. So then if we want to come down here, that's 3 quadrants. So that's 3 pi over 2. And that doesn't reduce, so we leave it like that. So then to finish going around 4 quadrants, that would be 4 pi over 2, and 4 over 2 will reduce to 2 pi. So going all the way around a circle in radian measure gets us from 0 to 2 pi. So 360 degrees and 2 pi are equivalent measures. So a little bit of extra information to kind of help you further understand where all this is coming from. If you remember in geometry, and if you don't, that's fine, we're going to go over it. The circumference of a circle, which is the perimeter of the circle going all the way around, the formula is C for circumference equals 2 pi r. Where r is the radius, the length of the radius of the circle. Now I said for this unit circle, we're going to say that the length of the radius is 1 unit. Whether it's feet, inches, meters, doesn't matter. 1 unit. Because the size of the circle can change based on the length of the radius, but the angles are always going to be the same. So it doesn't matter if I have a circle with a radius of, I don't know, ½ an inch, or a circle with a radius of a mile. If the angle is 90 degrees on the little circle, it makes a right angle. If the angle is 90 degrees on the giant circle, it still makes a right angle. So the angles don't change with the size of the circle. The angles are consistent. So for the unit circle, we use that to talk about angle measure. So we can relate it, and then after we solve a problem for the angle, we can relate it to our problem that we're trying to solve in real life or whatever the situation may be by changing it on the radius size of our example. So what I'm saying is that the unit circle, the radius equals 1. Yes. So we can, because it's simple to work with 1, right? Like if I'm going to multiply by a number by something, 1 is nice because it's easy to work with. So then, this formula, the circumference of the circle is equal to 2 pi times the length of the radius. But if the length of the radius is 1, then the circumference of the circle is equal to 2 pi. And that's how we get to this being 2 pi. Is if we make the radius 1, then all the way around the circle is 2 pi. And then we can solve for our angle, and if we want to know for a circle that has bigger than a radius of 1, we can apply that information. Okay, so the only other part we have is conversions. I'm going to go ahead and go to a new piece of paper because it won't all fit right here and I don't want to split it. So here we go. Conversions, part 2. So if you're given an angle in degrees and you're told to turn it into radians, then you can use this conversion factor and multiply by pi over 180, 180 degrees. Because if you're in degrees, your angle has degrees in it, and you wanted to go into radians, remember I said every time you're in radians you're going to have a pi in it. So your degree measure is not going to have a pi. So you're going to need to multiply by pi so that you have a pi in your measure. And you need to get rid of the degrees, so you're going to divide it by 180 degrees because that's the degree for a single pi. For example, if I tell you to convert 120 degrees into radians, use your conversion factor. You're going to multiply it by pi over 180 degrees. Since I'm dealing with a fraction, I want to make my 120 degrees a fraction by making it over 1. And then when I look at this, I have 120 degrees in the top. So I have degrees in the top and degrees in the bottom. So degrees can cancel degrees. So now my degrees are gone. So this is 120 pi divided by 180. So now I just need to simplify 120 over 180. Well, if I have a 0 and a 0, I know that's divided by 10, and the zeros go away. Then I have 12 over 18. 12 and 18, I can divide both of those numbers by 6. So if I divide 12 by 6, that's 2. If I divide 18 by 6, that gives me a 3. So this equals 2 pi over 3. So 120 degrees is equivalent to 2 pi over 3 in radians. All right, so I have one for you to try. I showed you how to do it. Now you try one. Negative 35 degrees. Convert that into radians. Negative 35 degrees. Okay, so if you have radians and you want to go 2 degrees, that's going the opposite direction, you're going to multiply it by the reciprocal of degrees to radians. So this was pi over 180, so you can do 180 degrees divided by pi, because that means that you have radians, so you have something with a pi in it, and you want to cancel the pi, so you need a pi in the bottom. And that puts the degrees in the top. So for an example here, we have 5 pi over 6. And I want you to convert it into degrees. So as long as you can remember pi and 180 degrees are the two big numbers, because that's halfway around the circle and they're equivalent to each other. If I have 5 pi over 6, I know that I need a pi in the denominator to make that pi cancel. And so then I have to put the 180 degrees on the top. So then my pi's cancel. So I have 5 times 180 degrees divided by 6, which is 900 degrees divided by 6, which is 150 degrees.